So for today, our topic is integration. So as we in last class had got in a thorough detail of this integration, and we are doing this integration in much more detail. And it is not just it has limits of till antiderivative, but it is not bound with limits, and it is more than that. Integration in simple is that how can we find that area, and that you do in the application of integrals in area of bounded regions. So in today's class, we are not doing area of bounded regions, but we are discussing all the examples and integration. The main is for our topic is integration, how to solve it, and tips and tricks of integration. So okay, so for our first question, as we are able to see, is this. Okay, so I am yes. So now we can separate in integration. Okay, so if we are able to separate in integration. So as we are able to start 2a upon root x. What would be that? 2a upon root x would be can be written as 2a into x raised to the power of 1 upon 2, as we are able to see. And we are separating now. We are separating it. In integration, we can separate terms. If it is integration a plus x dx, then we can separate it and write as integration a dx and plus integration x dx. Okay, so that we can do. So first one like this, and the second one b into x raised to the power minus 2, and the third one is 3 into x c into x raised to the power 2 upon 3. Okay, so we can just we are simply differentiating. We are making it terms and terms. And now x raised to the power minus 1 upon 2, as you are in the formula, it should be x into n plus 1 upon n plus 1, and we would add this formula, and other except all the coefficients of x is constant here, and therefore 2 is constant, and it is simply given it's WRTX, so therefore it is so it's with respect to x, and therefore we would treat a as constant, and we are able to see the answer. It would be as we have solved, and what it would be, x raised to the power 2 plus 3. So what would we write? X raised to the power 2 upon 3 plus 1, that is x raised to the power 5 upon 3 upon 2 upon 3 plus 1 would be 5 upon 3. 3 would go upwards, so 3, and there was 3 ones before only, so 9c, x raised to the power 5 upon 3 and upon 5. Okay, so this was the basic concept, and now moving further in the examples theory, and here is a normal question coming. So for this, we have to know that what is t dt. It's about t dt, and we should know what is t dt. And for as we are right now doing that antiderivative. So antiderivative, we should know how can we do antiderivative. Okay, so if antiderivative is y equal to x, if y equal to x is the equation, then we can write dy upon dx equal to dy upon dx equal to 1. Okay, so that we can write, but I don't want to write this. I want to do here, can I write if I am putting that x is equals to v. Okay, x equal to v. Here I am putting this equation. Then I can add that dx equal to dv. Like this only I would write here, as we are also getting y equal to x, or dy equal to dx. If we are bringing x to RHS. Okay, so we therefore get this value, and this is what we are doing. So our target now is very much clear. We can if we are writing like v equals to, here we always in 90% cases we take the whole denominator as v, y, anything. So I am taking here, it is b given, but I can take as t. Why t? Because t is the main thing, and we namely call it as t. So t equals to, what is the denominator, b square plus c square cx. Okay, so this is what we are doing. So now what we should understand, it is with dx, meaning with respect to x, and if you would look clearly, that b is constant and c is constant, so nothing worry of that. So t equals to these both are constant, and we know that here we would do derivative. So the derivative of t would be dt, and derivative of b square, meaning constant of the derivative of constant would be always 0. Okay, 0. and then at last it is c square x. Now it is c square x. What is the reason of c square x? So c square is constant, so we directly write c square into the integral x square. So the integration of x square would be 2x, so 2c square x. Okay, so as we are able to see, it would be dv equal to 2c square dx. Okay, now we can put this value here, and if we put this value here, okay, so if we are able to put this value here, then we would easily get the answer. Yes, so we would get this value, and like we are able to see 3ax. 3ax is, we don't need 3ax, so what can we do? 3a is constant, so we can put it outside the integration sign as it is constant, and the derivative of constant is 0. Okay, so we are not removing 3a, but we don't need to integrate 3a. Okay, so we would treat it as a constant only. Neither ways. Okay, so here in this equation we are treating 3a as constant, and what we need is x dx. Yeah, we are getting x dx, but we also need 2c square. So for this 2c square, we would divide and multiply 2c square. Okay, so 2c square divided and multiplied. Okay, so we are multiplying and dividing, and therefore 2c square and x, so x dx, and so therefore this would be dv, this whole would be dv. Okay, so this whole would be dv. So 3a upon 2c square is constant, and this we got as dv upon v, took the denominators as v, and therefore the integration of dv upon v would be always log v. So 3 upon 2c square log v, and as we know, we had put the value of v as b square plus c square x square. So we can put the value here of v as b square plus c square x square, and we get this answer like this. Okay, so moving further, so we get verify the following using the concept of integration as an antiderivative. Okay, so it is saying that verify the following concept. We have to verify that concept. Okay, so we know that it is a concept and it is not wrong. It would be true everywhere. Okay, now we have to verify it here. So what is our concept, and we have to show that antiderivative and integration is same as the antiderivative. So if we would integrate of this, we would get this, and if we would like if I do the integration of x, I am getting that it would be x square upon 2. Okay, and so if I differentiate x square upon 2, I will get the value of x. So we have to show that yes, integration is an antiderivative here. Okay, so that is our main topic here. Okay, so this I would like to here show. Okay, so how I would show is like here, and now first we would integrate. So how can we integrate x plus 1? In many ways it is difficult, but how I do is easy. Okay, so can we write x cube plus 1 upon x1 plus 1 minus 1 upon x plus 1. Okay, so can I write like this? Yes, I can write. And now I would differentiate it. Not differentiate. I would now remove the numerator, and I can now separate x cube plus 1 and minus 1. Okay, as I can write plus 1, I can add plus 1 minus 1, as plus 1 minus 1 is 0. So now comes x cube plus 1 upon x plus 1. So what would be x cube plus 1 upon x plus 1? So x cube plus 1 upon x plus 1. Can we think of how can we calculate x cube plus 1 into x plus 1? So easily thinking, if we are able to easily think that it is aq plus bq, and it would be a plus b, that is x plus 1 only, into x square plus x plus 1. Okay, so this would be a remainder here left, and we are also with minus 1 upon x plus 1. Okay, so we would solve this by log v, and that would be minus log x plus 1. Okay, so this would be for for minus 1 upon x plus 1, we can directly write log x plus minus log x plus 1 and minus log x plus 1, as here it is also in RHS. And now we can indirectly integrate this. Okay, so how can we integrate this? X square can be written, we are integrating, so x square can be written as x cube upon 3 plus x square upon 2 plus x. Okay, so here we are easily able to integrate, as it is the power of x, and we know the formula, x is to the power n plus 1 upon n plus 1. Okay, so this is the main formula that we have to use mainly. Okay, so now moving further, we have one more question. Okay, so slowly and slowly the concept would increase, as you should know. And now we have to first think, how can we make it easy and simplified, as we have to remove root under from numerator. The main concept is we have to remove the root under from numerator. So to remove it, we can multiply root under 1 minus x upon root under 1 minus x. Okay, we are multiplying 1, and 1 can be written as root under 1 upon x minus root under 1 upon root under 1 minus x. So we are multiplying this with the numerator and denominator. So okay, so we are multiplying this with the numerator and denominator. So how can we solve it? Okay, so how we were easily able to solve it as 1 plus x into 1 plus x, root under 1 plus x into root under 1 plus x would be 1 plus x upon, it would be root under 1 minus x square. Okay, this is a simple equation. And now we can separate the numerator, 1 upon root under 1 minus x square plus x upon root under 1 minus x square. Okay, so till here. Now 1 upon root under 1 minus x square. Okay, so integration of this would be sine inverse x. Okay, sine inverse x. And how can we check it? We can differentiate sine inverse x, and as integration is antiderivative of antiderivative, so how can we check it? We can check it only by one method, that differentiation of sine inverse x would be root under 1 minus x square, and this is the only method that we can check out. So moving further, and here we are able to see one more question, and our x we can take 1 minus x square as t, and then dt minus 2x would be dt, and then we can constant don't matter, constant we can change, like x dx equals to dt upon minus dt upon 2. Okay, like this as I wrote. Okay, so now the fifth question. The fifth question says that how can we solve this one? So this one is easy if I think. As if we think it normally, it is very easy. This question is very easy. So how can we remove this root under? And we have to take TDT. It is a simple TDT question. Okay, so to remove this, so can I do simply x minus alpha as t or t square, the same thing. Be safe from root under, I take t square. Okay, so if I take this as t square, okay, so if I take this as t square, meaning that x would be a plus t square, a plus t square. Okay, so this much clear. And now we can, in b minus x equation, now what would be b minus x? B minus x would be b minus brackets t square plus a. Okay, so this is a simple integration concept, and I told you how can we solve it. And now dt is done, so nothing is left. Like it is now, it is very easy. dt is done, and now we can directly solve. I mean by directly solve, like it would be, the equation would form as t square into beta minus alpha minus t square, and then we would multiply, and we would get beta minus alpha square and minus t square. That would be okay. So this would be the equation, and for dt it would be 2 from outside as constant, and minus 2, and that now it is simply as we are getting like this. And then we know now it is simple, and there is a formula for this also. It is, as I said, a square minus x square, that would be sine inverse. So that the formula says 2 is the constant before only, so I am not writing that is okay. Sine inverse x upon a. Now what is our x? Our x is t, so t and t upon a. And now what is our a? Our a is k. Okay, so now like this, and now we would convert t in the terms of x and alpha and remove all the constants. Okay, so we are done till here. Moving further, we should know. Okay, so this is a new